Hi students, welcome to the YouTube classes provided by NorthEastEdu-Science College. আমি আশা করি তোমরা সবাই ভালো আছো। আমরা গত ক্লাসে ডিসকাস করেছিলাম what is relation, how a relation is formed. To form a relation we need two sets, then we need the Cartesian product, and then we say that any subset, say R, is said to be a relation of A cross B. Now if there is only one set, that is relation on a set, means a particular set. Suppose there is only one set, then how I can define a relation? We know that to define a relation we need cross product. So how I can do my cross product? By taking A with A, means Cartesian product of A with itself, we will get the cross product. Then we can say that relation on a set by in this way: let A be a non-empty set, then any subset R of A cross A is said to be a relation on A. Okay, if there is only one set, then this is the definition of relation. Now we will discuss various types of relation one by one. So the first one should be our universal relation. What does the universal relation means? Universal relation. If I have two sets, then how I can define universal relation? And if I have two sets, then how I can define universal relation? I will show you one by one. Suppose there is two sets, then what will be the universal relation? The universal relation should be A cross B. Cartesian product of two sets is called the universal relation. Suppose there is only one set, then the Cartesian product of A with A itself is called the universal relation. So what the universal relation means? It means simply the Cartesian product of two sets. Or if there is only one set, then it is the Cartesian product of the set A with A. Or there is only set B, then it will be B with B. This is called our universal relation. Next one, identity relation. Identity relation. The definition says that a relation R is said to be an identity relation if and only if every element of A is related with itself. Every element of A is related with itself. Let us understand it by using example. Say 1, 2, 3. This is our set. Take two relation. 1 goes to 1, 2 goes to 1, 3 goes to 3. And second one, 1 goes to 1, 2 goes to 2, 3 goes to 3. This is my set. Always concentrate on your set. 1, 2, 3. There is 3 elements. The definition says that, the definition of identity relation, that every element of A is related with itself. Now see, 1 is related with 1, fine. 2 is related with 1, but the definition says that every element of A should relate with only itself. So here 2 relates with 2 is absent. Instead they are given 2 relate with 1, which is not our definition. So this will not my identity relation. 3 goes to 3 is there, but 2 is not there. 2 goes to 2 is not there. That's why it is not my identity relation. Come to this one, R2. 1 goes to 1, 2 goes to 2, 3 goes to 3. It follows the definition. What the definition says? The definition says that every element of A is related with only itself. It satisfies my relation. That's why this R2 is my identity relation. Have you got the point? So what we have discussed, we discussed universal relation and identity relation. Universal relation is nothing but the cross product or Cartesian product of two sets, or if there is a particular set, then universal relation is nothing but A cross A. And what is identity relation? A relation is said to be an identity relation if every element of A is related with only itself. We also discussed one example. Now go to next relation. This is called your equivalence relation. Equivalence relation. This is called equivalence relation, and this relation is very important relations. Questions are asked from this section. When a relation is said to be equivalence relation, a relation R on a set A is said to be an equivalence relation if it satisfies the following condition. Condition number 1, our relation should be reflexive. Number 2, relation should be symmetric. And number 3, relation should be transitive. So let us first write the definition. Let A be a non-empty set. Then any subset R of A cross A, not subset, any relation R of A cross A is said to be an equivalence relation if number 1 condition R is reflexive, number 2 R is symmetric, and number 3 R is transitive. This property is called reflexivity. This one is called symmetricity, and this one is called transitivity. So if my R is reflexive, symmetric and transitive, then we will say that the relation R is an equivalence relation. So this is the definition of equivalence relation. Now we will discuss one by one what do you mean by reflexive, what do you mean by symmetric, and what do you mean by transitive property. Please write the definition on your copy. Today I will discuss what is reflexivity property, and in next class I will discuss what is symmetricity and what is transitivity. So let us now see what do you mean by reflexivity. Reflexivity. First of all, write the definition. Any relation R on a set A is said to be reflexive if A, A belongs to R for all A belongs to A. Any relation R on a set A is said to be reflexive if A, A belongs to R for all A belongs to A. R is a relation on the Cartesian product, so elements of R should be in the form of ordered pair. Fine. This symbol means for all. If there is A, B, C, then it means what? image of A is A for all elements present in A. Now see, if I take one example, say capital A equal to A comma B comma C, and let us take two relations, say A goes to A, B goes to A, and C goes to A. Here it is take C goes to A, and take one more relation, say A goes to A, B goes to B, C goes to C, A goes to C. Now see, just apply the definition. For all elements belongs to A comma A belongs to R, means elements is related with its own image. Fine. In R1, first of all consider your set here A, B, C. So in the set R1, A goes to A, elements and its image is same, fine. B goes to A, okay, no problem. C goes to C, element and its image is same, C goes to A, okay. But remember, element B is in my A, but here B goes to B is not present. The definition says that for all elements belongs to A, element must be related with its same image, should be present in my relation R. But in R1, B goes to B is not present. That's why this is not an reflexive relation. Now go to this one. A goes to A, element and its image is same. B goes to B, same. C goes to C, same. All the elements of A are present here with their same image. It is one more element. It will create no problem. It will be there, it may be there or may not be there. It will not problem. But these three elements, depending on your set, must be there. If anyone is not in there, then it will not be a reflexive relation. Let us take one more example. Suppose A equal to A comma B comma C comma D. Then how I can make my relation reflexive? A comma A, first of all put all these elements with their same image. Now take any element, it will not create any problem. But this, depending on your set, these elements must be present there. Element must be related with its image and they should be equal. This is called the reflexive property, means all elements present in my set A, these elements must be in my relation. This is called the reflexivity, or the relation which satisfies this property is called an reflexive relation. Now I will discuss symmetricity and transitivity in my next video. So thank you.